right, welcome back. As I said, this one we're going to look at basically some of it's essentially nomenclature, also a big word for the basic terms that we need to know and discuss. Because when we talk about a mixture, what kind of mixture is it? There's different kind of mixtures. This is not getting into the nitty-gritties yet of chemistry. It's just starting to understand, you know, every discipline, every profession, if you like, has got its own jargon. Law has got its own jargon. A lot of it was Latin in the past. Engineering has got its own. Medicine's got its own. Accountancy's got its own. It's its own terminology. So essentially, we're going to be defining terminologies. What are certain things? When we're talking chemistry, we actually need to know this is a homogeneous mixture of that. This is a pure substance, okay? And a lot of it's reading work, and I would suggest you just summarize through, and we're just going to talk through very quickly this part, okay? Once it's very important, but it's mainly a session where it's going to be talk. We're just going to define these terms on their own. Well, let's have a look first of all. What is a pure substance, right? A pure substance is when it's in one form on its own, all right? Then it is pure. So if you've got a bottle of oxygen gas, that is a pure substance, right? If you've got basically carbon, a stick of carbon, once again, you've got a pure substance, right? Helium balloon, it's full of helium. There's only helium that's in there. It comes out of a canister. Very interesting substance. I mean, lighter than air, and you know, it does that great thing with the vocal cords at the end of the day. But that's a pure substance. Well, what is then a mixture? All right, it contains two or more pure substances, right? So, well, what is air? Okay, air is a mixture. All right, essentially, our pure substances are the substance on its own, right? So, for example, sugar, right? Sugar is a pure substance. It's sugar on its own. But when we put it into something else, water, right, we've mixed two things. We've mixed water, H2O, and we've mixed sugar, all right? And we're not going to go into the chemical symbol for that. But we've mixed the two. We've created a mixture. But let's think. If we create a mixture, we've got a mixture of, let's just make sure that I've got this over here. Let's draw our beakers over here, shall we? All right. And let's put in, just for the heck of it, let's put in water in this one and water in that one. All right. Now into this one over here, all right, I'm going to throw sugar or salt or whatever. Okay. We put it in there and we stir it around. Okay. Well, what do we know? It dissolves. The sugar or the salt goes into solution. It is dissolved, right? But it's a mixture, isn't it? We've got salt and we've got water. Sugar and water, they're mixed, okay, together, right? But now what happens if we do this, for example? If we mix substances like, for example, oil and, I don't know, vinegar and, I don't know, let's say mayonnaise or something else, right? We've got mixtures. Let's just leave, probably, you know, I'm not the greatest cook, but so let's just leave this out here and call it oil and vinegar that we mix up together, all right? Maybe lemon juice, for argument's sake. You notice that the oil sits on top of the vinegar, right? So we've got there a mixture of two different things, oil and vinegar, lemon juice, whichever you like, but they don't mix. The oil floats on top of the water, right? Incidentally, that's why you don't use water on a fire with oil, because you just spread the fire, don't you? The oil floats on the surface and the fire goes where the oil goes. So that's why we use different things, foams and things like that. But the oil and the vinegar don't mix. there's a distinct boundary layer between them. They're both mixtures, all right? Can you see here? We've got over here a layer, a discrete layer between the two. That over there, okay, that over there it's a heterogeneous mixture. Okay? Heterogeneous mixture. Heterogeneous mixture. That is one that's got layers. All right? The one that isn't got layers is called a homogeneous mixture. Okay? They're all put together. Okay? And you can't see the differences between the two. Can I get this back to the two constituents, oil and vinegar? Yes, I can. There's different ways. I can decant it, I can filter it, there's chemical, electrical, or physical processes we can do. Can I get the salt and the sugar back? Yes, I can. We can evaporate. That's how they get the salt out of the water with the salt pans. They put a layer of water in a very hot area, and what happens is it comes out out the top, right? That's the salt pan situation. The evaporation of the water leaves the salt behind. So we can break it back to its other constituents. For example, another homogeneous mixture would be something like air. All right? Let's look what's air. Air. Okay? It's a gas, isn't it? Air is a gas. Well, air is a mixture of a whole lot of different gases. Okay? I think there's nitrogen in there. There's definitely water vapor in there. There's definitely carbon monoxide. There's a load. Oh, hang on. There's our one that's quite important that we need. There's lots of different gases in air, right? That air is a mixture of the different gases. Can we pull it apart? Yes, we can. We can take oxygen out, nitrogen out, whatever we want to. That's a different process of chemistry, right? But yes, we can take them to pieces. The homogeneous mixture, okay, you can't see the nitrogen, right? Now, I know that you're going to say, yes, but hold on. There's that wonderful experiment where we've got, and you can actually do it, this is basically filled with a chemical compound in here, which is a gas, okay, which is heavier than air, okay? I'm not sure which one they use. The Freon comes to mind, but it's a heavier than air gas, right? It's not visible. And if you make a little paper boat, okay, it floats across, I'll actually look it up, but it floats across the sea of invisible gas. It looks like it's floating on air. Technically, it's floating on a gas that's heavier than air that you can't see. That doesn't have a distinct layer visibly, but as sure as heck it does over there and there. You've got air there, and you've got, let's call it gas A over here, all right, which is lying in there. That's another thing, for example, why if you're in a building which is burning, you don't lie on the floor. Why? Well, CO2, which is a byproduct, and CO, carbon monoxide, are byproducts of combustion. They are heavier than air, so they lie on the floor. In fact, CO2 are used in fire extinguishers. Because it's a heavy gas, it blankets the area that's on fire. What does a fire need? It needs oxygen to burn. And if the CO2 blankets it, it can't get the oxygen. It cannot get the O off the C, right? So that gas is heavy, it lies down. If you're crawling along a floor, right, you are sitting in that sea of gas, you will die. You will pass out, and then you will die. Because you will get what they call carbon monoxide or carbon dioxide poisoning, which affects the body because of the oxygen starvation. You'll go to sleep and you won't wake up again. Okay? So yes, we've got those processes, okay, in air. All right? We've got a metal, a steel, okay? Now, if you look, there's a lot of debate about, is it a homogeneous mixture or not? You know what? In this scenario, it depends on exactly what your textbook wants to call it. If you look at some advanced texts, they are mixtures. Some of them are homogeneous, some are heterogeneous. it's very much an issue. You go with what your textbook says, what the teachers are saying to you on this particular issue, right? I don't think it's a big deal. Liquids, sugar, water, we've talked about homogeneous. So the other thing we have to talk about is this word element. Okay? What is an element? An element is what we see on the periodic table. The periodic table is probably one of the greatest inventions in chemistry ever. It's recently just been added to at the bottom. The elements have been found. They're extra heavy elements. They're found in nuclear reactions. And they don't exist for very long. They exist for split seconds. And then they then say, right, we found it because it existed for a few microseconds or milliseconds or nanoseconds even, right? Right. Now, the element is the purest form of a single, let me say, item, right? Just let's leave it. Hydrogen, for example, helium, neon, argon, carbon, magnesium, sodium, all of those are elements. They are pure, they exist on their own, okay? Each one we're going to see a bit later has got a difference of an electron and a proton, sometimes extra neutrons. We're going to get to that. But the element is what appears on the periodic table. There's a few things to know about the elements. It is the simplest form of that substance that you can get. So if we've got hydrogen, that is the simplest form of hydrogen we can get. All right? We will learn that hydrogen exists as H2, a diatomic gas, very soon. But these elements are the building blocks. It's what we're going to build our chemistry on. Right? We're going to be building on the chemistry over and over. We're going to be mixing them like hydrogen and oxygen. Right? That's a mixture. All right? We're getting hydrogen, gas, and oxygen come together, and that forms what we know as water. Okay, so we've got water that comes in there, H2O. Okay? So we're putting these together. That becomes now let's say a mixture. We're starting to talk about compounds, right? Because they are things that are mixed together. Let's have a look at a few of these. They tell us copper sulfate, right? Now, first of all, copper is on the periodic table is a Cu, correct? Sulfate, this little guy over here, right, is an ion, right? Now, there's a download off the site, which is typical anions and cations, okay? I cannot overemphasize how important it is to know their names, their chemical formulae, and the thing that goes with it called the valency, okay? Don't worry at this stage what valency is, but make sure you've got that download or from your own textbook or a handout from school or college. Please not shrink wrap, plastic wrap that, stick it up at home, and make sure that when you're doing chemistry, you're going through those. I will guarantee you that it makes chemistry infinitely more easy. The reason being is when you know these valencies, the names, and the chemical formula, it cuts your processing time hugely. It will help you with oxidation reduction immensely. Right? Because that's where these ions come to play. So please learn them. They are simple metallic ones, and we are going to be going through them and how they're formed, but I would urge you to strongly look at them as basic building blocks because they are absolutely fundamental to what we're going to do. All right? So we've got things like that. We've got things like ammonium nitrate. That is NH4. NO3, okay? Can you see we've got nitrogen, hydrogen, another nitrogen, more oxygen. So we've got all of these atoms combining to form different chemical compounds. That is why I called the periodic table nitrogen, 4 hydrogens, another nitrogen, 3 oxygens, and then this guy comes and links to that one, all right? So we get molecules that come together and form. These are my molecules, right? There's a molecule. That's a molecule. It's a combination of atoms to give us a molecule. Okay? Now, as I said, this is, we're going to look in the next section. I want to look at the combination of how do we combine all of these atoms together? How do we name them? What are anions? What are cations? Okay? And what are the guidelines for chemical formations, all right? And ionically. We're going to go through that in the next session. Okay? So, this is just basically some of the names. We call it, say, if somebody said it's a mixture, heterogeneous or homogeneous, we know what it means, right? This is not the make or break stuff. It's just good to have this basic knowledge. Fundamental, anions, cations, okay? That's the basis of all of this lot. I'll be back, and in the next session, we're going to move ahead. We're going to talk about ions, etc., etc. Thank you.